Okay, we're now going to have a look at another major cause of the differences in energy balance on the Earth's surface, and this time it's at particular times of the year. We all know that in summer it's warmer, in winter it's colder. Why is that? Well, it's due to the seasons. Okay, so what are seasons? What's happening when the seasons change? Okay, so to understand this in a bit more detail, you need to understand two things that are controlling the differences in temperature that are affected by seasons. Okay, one is the angle of the sun at that time of year. If the sun is more perpendicular, it's going to be warmer. And the other thing is the length of daylight. So the longer it is daytime, the more energy the Earth can receive. Okay, so what's actually happening when the seasons change? So we should all know that the Earth revolves around the sun. All right, but just revolving around the sun doesn't change the amount of heat energy by itself. What you need to get seasons is a planet needs to be tilted, and ours is at 23.5 degrees. And what you need to understand is that tilt, the Earth stays tilted as it moves around the sun. Okay, so as this diagram is showing, the Earth is revolving around the sun, and you can see that it stays tilted at that same tilt, 23.5 degrees. Now, let's stop the rotation in, let's say, summer. And what can we see? Well, we can see that in summer, that tilt means that the southern part of the Earth is pointed more towards the sun, and the northern part is more pointing away from the sun. So that does two things. One, we probably know about, is that means we get longer daylight hours in the southern hemisphere, and the northern hemisphere gets shorter daylight hours. If you want to see why, have a look at the North and South Pole. You can see that the rotation of the Earth on a daily basis, its rotation, you can see that the South Pole is pointing towards the sun permanently in midsummer. So the sun actually never sets. Whereas the North Pole is pretty much permanently pointing away from the sun. So the sun never rises, and that's what happens. So, and then everywhere in between will get progressively less or more sunlight hours as you move away from the poles. The other thing that happens is that it changes the angle of the sun. So in summer, the southern hemisphere, the sun is more perpendicular than in the northern hemisphere. Now we can just change it to a winter month, and we can see here that the Earth has moved around to the other side of the sun, and we now have the northern hemisphere pointing towards the sun and the southern hemisphere pointing away. So for every unit of incoming solar radiation in summer, it's over a certain amount of area, but in winter, because of the angle of the sun, the amount of area that unit of solar radiation hits is larger because of the angle of the sun. You can see this diagram here. In the summer areas, that angle, the area over which that incoming solar radiation is smaller, so that per unit heats up more, whereas in winter, that same unit of heat energy is spread over a larger area. So you have less, that area is heated up less because it's receiving less energy. Okay, so that's why we have seasons.